Ladies and gentlemen, my name is Jeremy Purdy, and today we're going to be giving over a brief overview of the multi-point refueling system, better known as MPRS, on the KC-135 tanker aircraft. For those that don't know, the KC-135 is the United States Air Force's premier air refueling tanker. To give a quick little overview here of what the MPRS are, I'll show you to the slide. As you can tell, we have two aircraft, two F-14s, both refueling off of the multi-point refueling system hoses. The reason why this was added was to help the United States Air Force and the NATO allies help refuel some of their guys a little bit quicker and get them onto the fight. First off, some of the things we're going to go over through is some of the components of the multi-point refueling. First off is the actual pod itself, which if we take a look at the picture here, this is the MPRS pod itself. Right here is the most important part, the fan on the front of it. That pretty much has the whole entire aircraft while it flies. And as we can read on there, self-contained underwing store that delivers fuel from the tanker airplane fuel system to a receiver airplane at a flow of about 400 gallons per minute. This is operated by the boom operator sitting in the back of the aircraft, who has a pod back there that looks at. It has an internal fuel system, and this fuel system is what powers and runs everything on the aircraft, or for the MPRS pod itself. First and foremost, it provides braking power to control the extension and the retraction of the hose. This way, it knows when to stop, so it doesn't let the whole hose out the back of it and close it on top. Provides hose for when the receiver aircraft actually pushes into it, because that's how the system works. It provides tension. It says, okay, you're in contact now, I'm going to let you push me all the way in, and we're going to start fuel flow. And it's to increase the fuel flow and regulate pressure to transfer fuel to the other aircraft, which basically means, like I said earlier, once he gets in, it's going to say, alright, he's in, now we're going to start giving it gas. Or we don't give it too much gas, just gas. The boom pod, which I'm trying to get a better picture of here for you right here. This is for the right hand side and left hand side of the system, and all the various knobs, how much gas we're going to give them, how much they have, rewind, hose jettison. This is located in the back of the aircraft, in the boom pod where he sits. It's the left hand side as you're looking down on the system. Well, some things that are good to know is that if you just have one of these installed in the aircraft, you cannot take it. Obviously, that's going to show a pretty heavy imbalance between the right and left of the aircraft. And that means one wing to be more winged down than the other, and that's an unsafe flying condition. Another thing to note is that if the receiver aircraft that's coming in gas, that's what the receiver is, if his wingspan is greater than 68 feet, himself will not get two of them on at the same time. The reason for that is they're going to be in close proximity to each other in contact, and in case one of them has problems, we'll be able to get away from the boom. Also, on the first picture, you can actually add a basket for these pro type levers, and you'll put them on the actual boom itself on the aircraft. But we cannot refuel two people on wingtips plus on that boom for the obvious reason of they're going to be in close proximity and they're going to hurt each other. Also, depending on the outside air temperature and how fast we're going, we can or cannot be able to refuel. Obviously, if it's really cold and we're talking around 54 degrees Celsius, we just can't really refuel in those conditions because it'll up and the fuel won't be able to get transferred to the aircraft. And just to let you know, a couple pictures here. The hose length, the full trail, is 74 feet. So we're talking from the beginning of the pod out to the very end of is 74 feet on both sides of the aircraft. And as I mentioned the boom earlier, there's a boom that's stowed right now. Another thing to note that when we're refueling the AV-8B Harriers, the jets that take off vertically from anywhere in the world, they can only be refueled in this type of system. While they do have a probe, you cannot refuel these guys with the boom BDA, because the BDA itself is actually a really hard material and it can actually damage their aircraft. And So also, when we're looking at this system, we have several emergencies that can possibly happen while going on to this. One of the most common ones is that the pod fails, just for whatever reason, for some reason. Two things you need to look for when this happens if the pod fails. One, the hose is either completely inside of the MPRS pod itself, or the other one's going to be, is it out in trail position. The only way to know if it's in full trail position will be, if we're looking at this picture again, there's a light here that says full trail. As you see, it's pod failed. It says fail right here, which I'm trying to zoom in for you. Full trail. That right there is an indication of pretty much your best case pod failure. The hose is out, it's a full trail. Basically, all you're going to do is simple enough. Turn on and off the system several times. That's all it requires. Keep turning it on and off, it'll eventually somehow heal itself. No one knows how, no scientists or engineers can explain why. But that's your worst case scenario. And another question is, what happens if the receiver comes in and he breaks off his probe? Well, here's an indication. Here we have the basket itself. The red spot there is an F-18 receiver probe. Happened to me when I was deployed once. Luckily, that's a nice clean break as we're looking in here. All you have to do at that point is just rewind the hose and call it a day, because obviously you're not going to be able to get another guy onto the aircraft. Now what happens when the pod fails? As we see here, but notice the light isn't on, that light's not on, it's a complete failure. This is the worst case scenario. Basically what's going to happen is you're going to have to land with the hose and trail. Why don't you just get rid of the hose, cut it off, and land normally, as called the hose jettison? Well, the reason why we can't do that is the system only will do that if it recognizes it's in trail. So if that light is not on, it will not come on. So there's you coordinate with the pilots up front, and obviously with our ground, let them know that you're going to. It's called FOD, forward object debris. You're going to take down the runway for about 20-30 minutes because you're going to land and drag, and people are going to have to pick up some pieces. But what happens when we land in trail? Well, ladies and gentlemen, that is it. That is all the damage you're going to see to the aircraft. That's the basket itself, and as you can tell, that is actually, from what I was told, a $200 fix. All it costs to fix it. So most people thinking, just jettison it, lose it, come land. Well, you do that, you just lost the hose. I forgot how much that was worth, but that's a $200 fix. It breaks down the runway. Obviously, a lot cheaper than replacing the whole entire hose. And just to give you a little overview of what we talked about a little bit of the components of the system, what to look for, some of the distances and the functionality of it, and what to do in case of emergency. Again, I am Jeremy Brady. I am on the tanker, and I hope you all enjoyed this informative speech I just gave today. Thank you very much.